Hello everyone, welcome in a new video. In this video we are going to understand the concept of longest job first, LJF, that what is basically LJF, what is its scheduling criteria, and we are solving some questions on this topic. Okay, LJS is generally this type of a question generally occur in a gate examination. Okay, not generally, sometimes, but definitely on this topic the question arise in the past few years. Okay, that's why we are understanding these things. Longest job first. Okay, so in practical way, if we understand these things, longest job first, there is no use of this scheduling algorithm. This scheduling algorithm is used to create the questions to test the student basically. Okay, why this is not in a use? Because by its name it says that longest job first. It means what? It means that in this scheduling algorithm, those process who have a very high burst time will get the CPU first. Process who have a very high burst time will get a CPU first. Okay, so we see that if the long process get a CPU, then it means what? It means convo effect will occur. If convo effect will occur, then definitely the scheduling algorithm will of no use. Okay, so we can understand this with an example as well. We have a CPU. If let's say P1 is a process who have a very huge burst time, and P2, P3 is a process who have a very small burst time. Let's say the burst time of P1 is 100 and burst time of P2 is 1 2. So what happen if P1 get a CPU? Because we are discussing LJF, longest job first, and P1 have a high burst time, so definitely it will get a CPU. If P1 get a CPU to execute, it take a lot of time to terminate. This process will take lot of time to completely execute and terminate. Okay, so if this process taking that much time, and those process who have a very small burst time not get a CPU and get a CPU at a very long time, this process get a CPU at a very long time. Okay, so that's why this is what a disadvantage, that lot of process will not get a CPU. Lot of process will not get a CPU because of one process will acquire CPU for a long period of time. Okay, that's why we are not using these scheduling algorithm. Okay, what is it? Scheduling criteria. So scheduling criteria is very simple. At what we do, this is what a scheduling criteria, that we have to select that process who have a very large burst time, who have a highest burst time. Okay, so schedule that process which have with largest burst time, so we have to select those process who have a very high burst time. And what happen if there is a tie between the burst time? So if tie there between the burst time, then we have to follow the condition of FCFS, first come first served condition. Those we have selecting those process who have a smallest arrival time, Okay, so this is what a situation occur if there is a tie between the burst time between the processes. Now type of algorithm. What type of algorithm is this? So this is a non-preemptive type of algorithm. What does that mean? That means that if a process get a CPU, it will leave CPU only when the process is completed. Okay, it not like the other processes like SJF means the other preemptive processes where operating system snatch the CPU from a running process. Why? Because some other process who have a highest priority than the running process. That's why what operating system do? Operating system snatch the CPU from a current process and give CPU to the priority process. Okay, so these things not happen in this scheduling algorithm. If a process get a CPU, it execute completely. Okay, so now let's solve some question of this topic. Now we have a process. What you have to do is you have to simply find out the turnaround time, average turnaround time, and average waiting time. So processes, we have 4 processes, all of them having a 0 arrival time and burst time is 6 3 4 2. Now what you have to do is you have to solve this. Pause the video and try to solve these question by yourself, because it's a very easy question. You can easily do that. Okay, so now first of all what we have to do is we have to make a Gantt chart. So Gantt chart, 0 at 0 arrival time, we have one process available. We have all the processes available, but we have to select those processes who have a very high burst time. So between these 4 processes, P1 is a process who have a very high burst time 6. So P1 will get a CPU, P1 get a CPU, and this is a non-preemptive process. So if a process get a CPU, it will execute completely. So P1 will completely execute. After that, we have 3 processes. Among these 3, whosoever have a highest burst time will get a CPU. So after P1, P3 is a process. So P3 will get a CPU. Burst time is what, 4. So 6 and 4, 10. After that, P2 and P4. So P2 have a highest burst time. So P2, now the completion time of P2 is become 13. After that, P4, and the completion time becomes 15. So this is how you solve the question. Now for the average turnaround time and average waiting time, what we have to do is we have to find out the completion time, turnaround time, and the waiting time, and find the average. So for the P1 the completion time is 6, for the P2 completion time is 13, P3 completion time 10, and P4 the completion time is 15. Turnaround time. So how we find the turnaround time? Completion time minus arrival time. So 6 minus 0 6, 13 minus 0 13, 10 minus 0 10, and 15 minus 0 15. Waiting time. Waiting time is what? Turnaround time minus burst time. So 6 minus 6 0, 13 minus 3 10, 10 minus 4 6, and 15 minus 2 13. So this is what waiting time, and this is what a turnaround time. So average is very simple. Average turnaround time is what? Sum of all the turnaround time divided by the number of processes. So 6, 13, 10, 15, it becomes 44. Divided by 4 processes. So 11 is our turnaround time. And average waiting time is sum of all the waiting time, 10, 6, and 13. So it becomes 29. Divided by 4. So 29 divided by 4, it becomes 7.2. So this is what average turnaround time and average waiting time, and I hope you understand these things, that how we find the average TAT and average waiting time in a longest job first scheduling algorithm. Okay, now we are solving one more question. So process, we have 4 processes, P1, P2, P3, and P4. We have 4 processes, and these four processes arrival time is 0, 1, 2, 3. This is what arrival time. Wait, after that burst time is 2, 3, 4, 2. This is what a burst time. Now what you have to do is you have to find out the average turnaround time and average waiting time. Okay, so Gantt chart, we have to make first of all the Gantt chart. Remember this thing, this is a non-preemptive process. So if process get a CPU, it will execute completely. Okay, you cannot snatch the CPU from a running process. So at 0 arrival time, we have only one process available, which is P1. So we have to execute P1 0 to 2. After that, P1, after 2, we have 2 processes available, P2 and P3. So now between these 2 processes, whosoever have a highest burst time will get a CPU. So P3 will have a highest burst time, which is 4. So P3 will get a CPU, and 4 and 2 become 6. After that, after the P3 process completed, now we have 2 processes available, P2 and P4. So P2 will have a highest burst time, so definitely P2 will get a CPU. P2 burst time is 3, 6, 3, 9, and then P4 6, 3, 9, and then P4 burst time is 2, so 9 and 2 is 11. So this is what the Gantt chart, and this is what a completion time of the different processes. What you have to do is you have to find out the average turnaround time and the average waiting time for this particular process. So I hope you can do these things by yourself. Okay, it's easy. Find completion time is given, subtract completion arrival time from a completion time, you will get turnaround time, and subtract burst time in turnaround time, you will get a waiting time. Sum of all the turnaround time divided by the process, you will get average waiting time, and sum of all the waiting time divided by the number of process, you will get average waiting time. Okay, so this is what a longest job first. It's a very easy thing, you can do it by yourself like what we do in this question. Now we talk about that how we solve this question. Now what is the advantage and the disadvantage? Let's discuss these things. Okay, so advantage. Okay, what is the advantage of this scheduling algorithm? So there is no advantage of this scheduling algorithm, none. Okay, so there is no advantage of this scheduling algorithm. Why? Because it in this for scheduling, what scheduler do? Scheduler choose that process who have a very high burst time. So definitely all the process are going a starvation. So all the other process will affect because of the bigger process get a CPU. Those process the remaining process will get a CPU after a very long time. So definitely starvation can occur, conway effect can occur. So many things happen. So that's why there is no advantage of this scheduling algorithm, and this scheduling algorithm is used nowhere in an industry. Now disadvantage. Now what is the disadvantage? There are so many disadvantages. Whatever you think, all are basically disadvantage. That what it suffer, the processes definitely suffer from a conway effect. So processes suffer from conway effect. What is the conway effect? Let's take an example that let's take this example. If there is a long road and there is a big truck, the road is like only one big vehicle can cross a road at a time. Let's say this is what a pull. Okay, only one vehicle can cross this pull at a time, and we have a truck. Okay, so and we have all other small cars, vehicle, and a different vehicles. Okay, so what happen if truck cross this bridge? So truck is basically a very heavy vehicle, very big vehicle, so definitely it move very slowly, and all the small vehicles may go fast, but in front of them there is a truck which move very slowly. So definitely all the vehicles will have to move slow because of one thing. Because of a one vehicle, all the other vehicles have to move slow. So this is what a conway effect is. In this scheduling algorithm, if we talk about the processes, so if one big process will acquire CPU, so all the smaller processes have to wait to get a CPU, have to wait for indefined amount of time. It can be very long. Okay, so if it is very long, but it's confirmed that that vehicle cross this bridge. So this is what happened in scheduling as well. It is confirmed that process will get a CPU, but when this is what we don't know. This is what the system don't know. So this is what a conway effect is, and in it the processes take indefined amount of time to get a CPU. Okay, after that we if conway effect occur, and the other disadvantage is that starvation is also taking place. Starvation for the shortest process, as starvation from shorter process. What does that mean? If we have so many processes like P1, P2, P3 and P4, let's take an example that we have 4 processes. P1 burst time is 100, P2 burst time is 99, P3 burst time is 98, and P4 burst time is what? Let's say 1. So now what happened? First of all, P1 will get a CPU, then P2 will get a CPU, then P3 will get a CPU. So you can imagine that how much time will it take, how much time the P4 have to wait to get a CPU. So it's a very long. And what happened when it execute P3, there are one big process also enter in a ready queue. Let's say we have P5 whose burst time is 500, and P6 whose burst time is 990. And after that, after the completion of a P3, what happened? It again check that which one have highest burst time, so it choose P6 because of his burst time. So if one small process is in a ready queue and very big processes are also there, so definitely the shortest bus time process have to wait for a very long time, or he never get a chance. So if never get a chance, that means it goes in a starvation. Or this process get a chance to get a CPU after a very long time, then definitely this thing, when the process have to wait for a very long time or indefinite amount of a time, then we say that this process goes in a starvation. Okay, so this is what a starvation, and this is what a disadvantage of this scheduling algorithm. And there is no practical use, there is no practical use. What does this mean? This scheduling algorithm doesn't use anywhere. Okay, so why this scheduling algorithm doesn't use anywhere? Because of burst time, because the operating system doesn't know about the burst time, that how much burst time the process will take. So if the operating system doesn't know about the burst time, then how basically the operating system execute that process. Okay, let's take an example to understand this thing as well, that we in a Ready queue we have a process. Let's say you are let's take an example that you are opening a WhatsApp and somebody calls you, you go to attend to basically talk to that person. What you do, you open a WhatsApp and somebody call you. So what you do, you terminate that process, you open the process, terminate the process. Okay, so how much time you open the WhatsApp? Not even a 1 minute. Okay, after some time when you free, you open that particular process again and you spend more than 30 minutes on that. So how operating system predict that your burst time for a particular process? Operating system can't, because sometimes you use 1 minute and sometimes you use more than 30 minutes. So definitely operating system cannot understand about the burst time, so that's why this is not in a use. Okay, so this is what a disadvantage of the scheduling algorithm and advantage of the scheduling algorithm. This is what LJF, longest job first. This is scheduling algorithm. This is all about in this video. Thank you for watching this video. Like the video and subscribe my channel, and definitely comment down the answer of average TAT of this particular process and average burst time, average turnaround time and average waiting time for this particular process. Thank you.